Hi friends, welcome back to engineeringtalks.com. In the previous two videos, we saw the introduction and concepts in detail. We found out the Laplace transforms of all the elementary functions. Then we saw the properties of Laplace transforms and even solved two problems using these properties. In this video, we'll solve more problems. So happy learning. And one more thing, don't forget to like, share, subscribe and press the bell icon. Find out the Laplace transforms of some of the functions. First, we'll consider a piecewise function f of t given by f of t equal to cos t when 0 less than t less than 2 pi and f of t equal to 0 when t greater than 2 pi. Laplace of f of t is given by, we all know, integral 0 to infinity e raised to minus st f of t dt. Now we can split this integral between the limits 0 to 2 pi and 2 pi to infinity. And within the limits 0 to 2 pi, we have the function value as cos t, and when t becomes greater than 2 pi, that is from 2 pi to infinity, we have the function value as 0. So we can write integral 0 to 2 pi e raised to minus st cos t dt plus integral 2 pi to infinity e raised to minus st 0 dt. This term becomes 0. Therefore, integral 0 to infinity e raised to minus st f of t dt becomes equal to integral 0 to 2 pi e raised to minus st cos t dt alone. Now, we can find the integral of this term using this formula. We saw this in the previous class. If you are facing any difficulty in following this, please watch the previous videos. So, according to this formula, integral e raised to ax cos bx dx equal to e raised to ax by a square plus b square into a cos bx plus b sin bx. So, here in the place of a, we have minus s, and in the place of b, we have 1. So, when we substitute, we'll get integral 0 to infinity e raised to minus st f of t dt equal to integral 0 to 2 pi e raised to minus st cos t dt, which is equal to e raised to minus st by s square plus 1 into minus s cos t plus sin t within the limits 0 to 2 pi. Now we'll apply the limits. First we'll apply 2 pi. So it becomes 1 by s square plus 1 into e raised to minus 2 pi s into minus s cos 2 pi plus sin 2 pi minus e raised to 0 into minus s cos 0 plus sin 0. Now cos 2 pi is 1 and sin 2 pi is 0, and cos 0 is 1 and sin 0 is 0. So from this bracket we'll have only minus s, and from this bracket also we'll have minus s. So it becomes 1 by s square plus 1 into e raised to minus 2s into minus s minus, we'll have minus s from this bracket as well. So minus s. So this gets reduced into 1 by s square plus 1 into minus s e raised to minus 2 pi s plus s. Now we'll take the s outside. It becomes s by s square plus 1 into 1 minus e raised to minus 2 pi s. Let's move on to the next function. The next function f of t is equal to cos at plus b. So, Laplace of f of t is equal to Laplace of cos at plus b. But according to the formula cos a plus b, we have cos a cos b minus sin a sin b. So, we can substitute here. That is cos at cos b minus sin at sin b. So, Laplace of cos at plus b becomes equal to Laplace of cos at cos b minus sin at sin b. Now, by using the linearity property which we saw in the previous class, we can split the terms. So, Laplace of cos at cos b minus Laplace of sin at sin b. Now, since cos b is a constant term, we can take this outside. So, cos b Laplace of cos t minus, similarly we can take sin b outside. So, sin b into Laplace of sin a t. So, cos b into s square by s square plus a square, because s by s square plus a square is the Laplace transform of cos a t, minus sin b into a by s square plus a square, because a by s square plus a square is the Laplace transform of sin a t. Therefore, it becomes equal to s cos b minus a sin b by s square plus a square. Now let's find out the Laplace transform of the function e raised to t cos h 3t. This is of the form e raised to at f of t. So Laplace of e raised to at f of t is given by f of s minus a using first shifting property. If you are facing any doubt, please watch the previous videos. So let's find out the Laplace transform. Laplace of cos h 3t is equal to, we know, s by s square minus 3 square, which is equal to s by s square minus 9. Therefore, Laplace of e raised to t cos h 3t becomes equal to s minus 1 by s minus 1 the whole square minus 9. Is f of t equal to sine cube 5t. So for solving this, we should know the expansion for sine cube t. So sine cube t is equal to 3 sine t minus sine 3t by 4. So Laplace of f of t is equal to Laplace of sine cube 5t, which is equal to, we'll substitute this formula here. That is 3 sine 5t. Instead of sine t, we'll write sine 5t minus, instead of sine 3t, we'll write sine 3 into 5t, because here it is sine cube 5t. So it becomes sine 15t by 4. Therefore, by linearity property, we can split the two terms. So it becomes equal to 3 by 4 Laplace of sine 5t minus 1 by 4 Laplace of sine 15t. 3 by 4 into Laplace of sine 5t is given by 5 by s square plus 5 square minus 1 by 4 into Laplace of 15t is given by 15 by s square plus 15 square. Then it becomes equal to, we'll take this 15 by 4 outside, it's common. So 15 by 4 into 1 by s square plus 25 minus 1 by s square plus 225, because 5 square is 25 and 15 square is 225. Then it becomes equal to 15 by 4 into this bracket. When we solve this, we'll get 200 by s square plus 25 into s square plus 225. Now 4 into 50 is 200. So 50 into 15 becomes equal to 750. So the final value will be 750 by s square plus 25 into s square plus 225. Now let's find out the Laplace transform of the function e raised to minus 4t minus t square e raised to 2t plus 4 sine 2t. This function consists of 3 terms, so we can split the terms like this and find out the Laplace transform of each of the terms individually. Let's first consider the first term, e raised to minus 4t. Laplace of e raised to minus 4t is given by 1 by s plus 4, because Laplace of e raised to minus 8t is given by 1 by s plus a. Here a is equal to 4. Now the second term, t square e raised to 2t. According to the first shifting property, we have Laplace of e raised to at f of t is equal to f of s minus a. Here, in the place of f of t, we have t square. So, first we will find out the Laplace transform of t square, which is equal to 2 factorial by s square plus 1, which is equal to 2 by s cube. Therefore, Laplace of e raised to 2t, t square is equal to 2 by s minus 2 the whole cube. If you are facing any difficulty in following this, please watch the previous videos. We found out the Laplace transforms of the first two terms. Now the third term is 4 sine 2t. So Laplace of 4 sine 2t is given by 4 Laplace of sine 2t. 4 is a constant, so we will take outside. Laplace of sine 2t is equal to 2 by s square plus 2 square, which is equal to 4 into 2 is 8. So 8 by s square plus 4. Now we can combine and write Laplace of e raised to minus 4t minus t square e raised to 2t plus 4 sine 2t is equal to 1 by s plus 4 minus 2 by s minus 2 the whole cube plus 8 by s square plus 4.